Hello, grade 12 here, Mr. Jim, and we're going to do another video on physical properties, probably the last one on this topic for now. Now, this video is going to be about the relationship between physical properties and surface area. In the last video, we spoke about physical properties and homology series. So let's first recall what boiling point, melting points, and vapor pressures are very fast. Boiling point is the temperature at which the vapor pressure of a substance equals the atmospheric pressure. Second, melting point is the temperature at which the solid and liquid phases of a substance are at equilibrium. And vapor pressure is the pressure exerted by vapor at equilibrium with its liquid in a closed system. Now, let's go to something new. For compounds of the same homology series, these ones are the same homology series. So all of them are alkanes, or all of them are ketones, or all of them are carboxylic acid. Now, what happened? The longer the chain, the larger the surface area. Okay? For example, a compound butane is longer than ethane, and hexane is longer than butane. That is what I'm talking about. Okay? In a straight chain. The longer the chain, the larger the surface area. And the compound will have more sites for London forces. So, if the chain becomes long, there are going to be more sites for London forces. So if you make the chain longer, what is going to change is the ability to form more or less London forces. Okay, so this one is the one. Remember, all compounds of the all homology series have, as well as the main intermolecular force, they also have London forces. Okay, so if they have more sites for London forces, more energy is needed to break the intermolecular force. Obvious, the stronger the intermolecular force, then the higher the boiling and melting point, the lower the vapor pressure. I think this is quite simple. Let's go to one example so you understand. Here, in this example, we have three compounds. First of all those compounds belong to the same homology series. So all of them are alkanes. You can see all of them are alkane. So that is the first important thing. All of them must be for the same homology series. Now, as you move from compound A to B to C, you're making the chain longer. So the surface area increases. Okay, you can see here the boiling point on the right hand side, and you can see that the boiling point also increases. So let's see how to explain that trend using the properties. Okay, all right. So what we have to say. Compound C has larger surface area than compound B, and compound B has larger surface area than compound A. That is the first thing. You have to compare the surface area. Okay, I'm going to do it in bullet, but you must do it in paragraph. Now, what is happening? The larger the surface area, the more site for London forces. So, compound C can form more London forces than compound B, and compound B can form more London forces than, let's fix that word quickly, than compound A. Okay? Now we are going to compare the strength. The intermolecular forces are stronger in compound C than B, and in B than A. Now we're going to the energy, more energy. Is needed to break, let's fix that word, needed to break the intermolecular forces in compound C than B and B than A. And finally, we go to the conclusion, okay? There is a conclusion. Therefore, you can do it in word. Therefore, compound C has higher boiling point than B and B than C. So this is the full explanation of that trend in terms of boiling point. Remember, if instead of boiling point is the melting point is exactly the same, and if its vapor pressure is exactly the same, but the opposite, remember, whoever has the higher boiling point will have the lower vapor pressure. So in other words, this one here will have now lower vapor pressure. Okay, so remember that is very important. Now let's see another example a little bit different. Now in this example we are going to see that the compound have the same molecular mass, so all of them are in actual fact chain isomers. Okay, so we have compound A, B and C, and we see that what is changing is that they come in more spherical. From A to B to C, they come in more spherical, so it's more branched than A. Now this one, remember, they have the same molecular mass, so that is important to know. Now as you move from A to B to C, the number of branched increases. So if the number of branch increases, then the surface area decreases. Okay, the explanation is the same. We'll just have to change few words here and there. I'm not going to write it, the video is going to be too long. You can try to do it. I'm going to write the answers right at the bottom, and then you can stop the video and compare. But very quick, this one will be like compound A have less branch than B, and B has less branch than C. Therefore, the surface area of compound A is greater than B, and B is greater than C, and the rest of the work is the same. More Landon forces will be formed in compound A than compound B, and more Landon forces formed in compound B than C. More energy is needed to break the intermolecular forces in A than B than C, and therefore higher boiling point and melting point in A than B and in B than C. So that is this other example I wanted to say, because in this case now the molecular formula is the same. So thank you for watching the video. I hope it helped. It's not very difficult topic, and then the next video, even though I wanted to do a question on this topic, we are going to make a video on reaction. We're going to start with the reaction because the time is short and you people will be writing the test very soon. Okay, thank you for watching, and good luck.